Yo, 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 yo. Hello, everybody. Thank you for tuning in. We're going to factor special cases. So this is our last video of this topic. So thank you for watching, and let's just get straight into it. You have to know how to factor at this point. So if you don't know how to factor quadratics, please watch 7.5 and 7.6 first. So perfect square trinomial, these are your formulas for it. With that being said, for a perfect square trinomial, this is the formula if it's a perfect square where we're adding, and this is the formula if it's a perfect square and we are subtracting. Okay, we'll get into what this means. We've seen perfect square trinomials before, but now we're going to go the opposite direction. So what this is we have a perfect square trinomial. So the way we figure this out is this is just a shortcut. Okay, we could always factor this out like normal, and this one's pretty easy because it doesn't have a value here for a. But it's when it has a value here for a that this is going to really be a nice shortcut for you. But we'll look at it with this one first. So this one's a perfect square trinomial, and here's why. What we do is we look to see, does this c term, is this a perfect square? And if it is, that's our first indicator, like, okay, this might be a perfect square trinomial, because the square root of 49 is 7. Then I look to see if the value for a is also a perfect square. Well, that's just 1, and the square root of 1 is 1. So what I'm doing is I'm going to look to see, all right, well, if I take 1 and multiply it by 7, I get 7. But if I can double that, because that means we're going to end up multiplying these twice when we factor. If I double that, if I get the term that's in the middle here, the b term, that means it is now officially a perfect square trinomial. That's how we check it. So I find the square root of the c term, find the square root of the a term. If they're perfect squares, if I multiply those and then also multiply it by 2, if it equals this, it's a perfect square trinomial. Which means I take these values and I plug them in and then I square it. So because this 1 is in front of the x squared, the square root of 1 is 1. Now, of course, I don't actually need to write out that 1 there, but that's just showing you how this process would work if there is a value there. So it's really just x plus 7 squared. Square root of 49 is 7, and then I'm going to have this twice, so therefore it says x plus 7 squared is my final value. Now, if you would factor this like normal, you would have figured out, all right, what are my factors of 49 to add up to 14? Well, that's going to be 7 and 7. Well, x plus 7 is the same thing as x plus 7 squared. So this one right here, this perfect square trinomial pattern, isn't necessarily super useful, but like I said, it's really useful when we have a value, when we have something here for a. So like, let's look at this one for example. So this is where I got some big numbers. I would have to do 9 times 25, and then I would have to figure out, that'd be 225, factors of 225, that add up to negative 30. It's one of those ones where with these larger numbers, it's kind of a pain. But if I notice, 9's a perfect square, 25 is a perfect square. So if I look at the square roots of 9 and 25, that's 3 and 5. Well, 3 times 5 is 15. 15 times 2 is 30, which is what my middle term is. So this is a perfect square trinomial. So because this one's 3 and this one's 5, that's going to give me 3x and 5. But this one I'm going to end up subtracting them. And the reason why is just because that's a negative. Negative 5 times negative 5 is still going to give me my positive 25, but then now when I do 3 times 5, when I actually were to multiply this out, and I would have negative 5, it'd give me negative 15 and negative 15 to give me negative 30. So if you have a negative sign here, then you just put a negative sign here, and then you're all done. Obviously, if this was a negative sign, then it's no longer a perfect square trinomial because it's negative 25 is not a perfect square. I can't multiply the same value to get to negative 25. So perfect square trinomial, find the square root. If they multiply those and we double it, if it equals this value, then we have this shortcut and this pattern to work with. Now, another pattern is the difference of squares. So same idea, this is when we have a perfect square and we have a perfect square. Now, if I notice though, for x squared minus 9, this doesn't have a middle term. So this would be a difference of squares when there's no middle term and we only have the a and then the c, and we were missing that bx in the middle. Well, let's look at it as if the bx was there. That would just be 0x, because 0 times x is 0, so I can write it in as 0. So I'm looking up factors of negative 9 that add up to 0. Well, that's going to be positive 3 and negative 3. So whenever we have 0 in the middle, that means we have to have the same exact number in both of our binomials. because they have to combine to make 0, and it has to be positive and negative. So that pattern here is called the difference of squares. Difference of squares is when we're adding and subtracting the same exact value. So what we do is we take the square root, and then we'll add and subtract those two things. So again, this pattern is really useful when you have maybe another perfect square here in the front. Okay, and when they're larger numbers. Now, this would be an example of a difference of squares, but this one looks a little bit more complicated. One, I got to make a quick adjustment. This is supposed to be a 3. It was just typed up wrong. Apologize for that. So fix that on your paper, please. Now, for this one, I'm looking for the factor form of 3x cubed y minus 12x y cubed. Now, the y sometimes throw people off, but we're going to treat it like it's almost not even there. But first, I want to see, these are cubic. I don't like cubes. We don't know how to factor cubics. We only know how to factor quadratics. So we're going to take out the greatest common factor first, which we should always be looking to do. So I can take out a 3, an x, and a y. Because they have 3 in common, I can pull out an x from both, and I can pull out a y from both. When I do that, I'm left with x squared. This y is now gone. This 3 is gone. Minus, this is going to become 4. This x is gone, and this is now going to be y squared. So now I'm just factoring out here. If I notice there's no middle term, and this is a perfect square, here's a perfect square, so it's a difference of squares. Difference means subtraction, right? So I'm taking the difference of two perfect squares, and this is the perfect square with y squared, this is the perfect square with x squared. Well, so I take the square root of the first value, again that's a 1, so it's just going to be x, and then that square root of x squared is x. And then the square root of 4 is 2. Square root of y squared is just y. And then I'm just adding and subtracting that. So it's x plus 2y, x minus 2y, and then the 3xy goes out in the front. I'm done. So they're same values in both binomials, except for we're adding and subtracting. And that's it. Go ahead and try these two and see how you do. So try to factor out this one and this one. But like this one, again, large numbers. So we want to see if we can figure out a way to use difference of squares here, if it's possible or not. This one right here might be a little bit easier too. So see what we can do, and then we'll go from there. So this one, I have a difference of squares. Square root of 4 is 2, and x squared is x. Square root of 81 is 9. So it should be 2x minus 9. 2x plus 9. So again, same exact values on each side, except for I'm just adding and subtracting. And I'm done. This one, these are not perfect squares. Okay, so it doesn't work. But I can also take out a greatest common factor here of 2. So because I can take out a 2, if I rewrite it, now it's going to be 25x squared minus, let's see, 16y squared. This is a difference of two squares. Square root of 25x squared is going to be 5x. Square root of 16y squared is going to be 4y. And that means I'm just adding and subtracting the 4y. And I'm done. So that, I think, is a lot nicer than having to deal with factoring this out the other way. Now, you're going to have some word problems as well. So what I'm looking at a cylinder, and I'm trying to find the radius of a cylinder that has a height of 3, and here is a volume. And a volume of pi times 27x squared plus 18x plus 3. So first, we have to know the volume of a cylinder, the formula. Well, volume of a cylinder is pi r squared times height. Okay, well, I already have the height. The height's 3. So the volume of a cylinder is pi times radius squared times the height. So there's a couple ways of doing this. Okay, so first, I want to make this look like this. Okay, so now if I even look at it another, I can even move this around, because you can multiply in any order you want. So this is 3 pi r squared. Well, I already have a pi, and I got to figure out what this is right here. So let me see if I can factor this to change this to multiplication, because multiplication helps us. So if I factor it first, I look for a common factor, greatest common factor, which is 3. I can factor out a 3 of all of this. So I pull out a 3, I got 3 pi in the front, because the pi is still here, so I just multiply the outside by 3. That's going to give me 9x squared plus 6x plus 1, because 3 divided by 3 is 1. All right, well, the 3 pi and the 3 pi, those look pretty similar, right? And we know that this is the volume. So now I got volume equals 3 pi, so this right here is automatically my radius squared, but I got to figure out what the radius is, not the radius squared is. Okay, well, then from here, what I can do is I can see if I can factor this out, and hopefully it's a perfect square trinomial. Well, perfect square, perfect square. Square root of 9 is 3. Square root of 1 is 1. 3 times 1 is 3. Times 2 is 6. It is a perfect square trinomial. So that means I'm going to have 3x plus 1 squared. So I had 3 pi times 3x plus 1 squared. If we notice, this and this are identical to each other, except for the r has been replaced with 3x plus 1. So my radius equals 3x plus 1. Another thing I could have done is I could have taken this formula and I could have plugged in the volume, which I'm given right here. So I know that the volume of this whole thing, I could have replaced this v and solved the equation. I would have had to still do the same work. This is a different way of looking at it. I could have replaced this v with 3 pi 9x squared plus 6x plus 1. Well, if I divide by 3 pi, divide by 3 pi, these cancel. I'd be left with 9x squared plus 6x plus 1 equals my radius squared. So then I would want to factor this out, which we just figured out is 3x plus 1 squared is equal to radius squared. So now if I take the square root of both sides, it gives me my radius, which is just 3x plus 1. So 2 ways to look at it. Okay, that's it. So that is all I got for you guys. Things to remember, because you're going to need this one. Put volume equals pi r squared times h, and that's of a cylinder. You're going to need to know that formula. I'm just going to tell you guys that now. Okay, that's it. Independent practice. Try it out. Thank you for watching. Good to see you out.